Hello all, welcome to the second video of the second lecture. In this video, I'm going to start with question 3 and then see how far I go. Alright, so question 3. Just to recall, we were talking about linear relationships and arithmetic progressions. So for question 3, a rental car company offers a rental package. The cost comprises a fixed $30 administrative fee for the cleaning and maintenance of the car plus the rental cost of $35 per day. Okay, so in question 3, X is going to be the number of days and number of days. See, yeah. And Y is going to be the total cost. Before I move on any further, let me reiterate that you are encouraged to work on the questions on your own or with your classmates before looking at the explanation. All right, so where were we? Construct a function to model a relationship between the number of days and the total cost. Okay, so we have to find the relationship between Y and X. In other words, how do we find the total cost from the number of days? All right, so it seems like this is a linear relationship from the fact that every day the cost goes up by $35. So if you think about it, if X increases by 1, Y is going to increase by 35. So we have that common difference of 35. We have arithmetic progression, and hence X and Y are in linear relationship. So let's have a look. Y is going to be something times X plus something. Okay, so we were talking about how the common difference is going to be the coefficient or the number that is multiplied by X. So as X increases by 1, we know that Y is going to increase by 35. So the common difference is 35. So 35 actually goes here. And what about the constant? In the previous video, we talked about how when X is 0, then Y actually just turns out to be this number. So what we need to find is when X is 0, what is Y? So it says the cost comprises a fixed $30 administrative fee. So when X is equal to 0, then all you need to pay is the administrative fee of $30. So when X is 0, Y is going to be 30. So this number here actually is 30. I hope that wasn't too hard. Question B. Again, if you have any questions or if you're stuck, or you can go back in the video, or you can always ask your friends or email me. All right, so question B, it's going to be kind of similar. So they actually give you the relationship in this question. Now the question is, what is the fixed administrative fee and what is the rental cost per day? In the previous formula, we were talking about how the number that is multiplied by X is actually the rental cost per day, because this is when when X increases by 1, Y increases by 35. So in this case, we can see that when X increases by 1, Y increases by 30. So the rental cost is going to be $30. And we were talking about how this $30 is actually a fixed administrative fee, which is equivalent to when X is equal to 0, when there's 0 days, Y just turns out to be 30. So in this case, when X is equal to 0, Y is 15, which means the fixed administrative fee is actually, is actually $15. Okay, hopefully question 3 wasn't too hard. Let's move on to question 4. All right, question 4 is a little more difficult because this question asks you to identify whether two quantities are in or are not, whether two quantities are in or not in a linear relationship. So let's have a look at it. 4a, okay. So there's a 3 by 3 by 3 cube. Sorry. A large cube falls into a bucket of paint, so the faces of the large cube are painted blue. And you broke the cube into unit cubes. Okay, so let me summarize what that actually means. So let's say we have a 3 by 3 cube. Let's see. Well, close enough. All right, so we have a 3 by 3 cube here, and what we're gonna do is we're basically by dropping the cube into the paint, it basically means we're gonna color all the faces that are on the outside. And once we do that, you can see that some of the cubes are gonna have 3 faces that are colored out of 6. Some are gonna have 2, and some of them are gonna have 1. So our first task is for a 3 by 3 by 3 cube, we need to identify how many cubes have 3 faces that are colored, 2 faces that are colored, 1 face that is colored, or no faces that are colored. Let's start with 3 faces. So in order for a cube to have 3 faces that are colored, the cube needs to lie at the corner. Like, so this is one, this is another one. So the question actually becomes, how many vertices or how many corners are there in a cube? And the answer is 8. What about 2 faces? In order for a cube to have 2 faces colored, they need to lie not on the corner, like not at the corner, but on the edge, like this cube, you can see. So the question actually becomes, how many edges are there in a cube? Well, in this case, it's equivalent because for each edge, there is 1 cube. So how many edges are there? There are 12 in a cube. Now, how many cubes have 1 face that is colored? Well, in order to have 1 face colored out of 6, the cube needs to lie kind of like in the middle of the face. So this is one of them. This is another one. So the question actually becomes, how many faces are there in a cube? Well, in this case, it's because there is 1 cube in the middle per face. So how many faces are there in a cube? And the answer is 6. How many cubes don't have any faces that are colored? Well, I don't know if you realized, but there's actually this hidden cube that is like right in the middle of the cube. You know, like the one that doesn't show at all from the outside. So the number of cubes that have 0 faces colored is 1, the one that's right in the middle. Just to double check, we need to see if these numbers add to 27, and they do indeed, because 3 by 3 by 3 is 27. So we expect the sum of these numbers to be 27. All right, that's great. But then that is not the end of the question. The question actually asks for 4 by 4 by 4 and 15 by 15 by 15 as well. And you're not supposed to count. All right, so, okay, this page is out of space. So let me get a new one. Oops. All right, so let's look at it for 4 by 4 by 4. Just have a quick sketch. Well, we shouldn't count, so it doesn't have to be like super accurate, but more. Close enough. All right, so again, we said, sorry, we said the number of cubes that have 3 faces that are colored are on the corner. And again, how many corners are there? There are 8. For looking at the number of cubes with 2 faces that are colored, they have to be on the edge, but per edge, how many cubes are there? Well, these are in the corner, so they don't count. There are 2 cubes per edge, and how many edges are there in a cube? 12. So it's going to be 2 times 12, which equals 24. looking at number of cubes that have one face colored, we're basically looking at the faces that are in the middle, or the cubes that are in the middle per face. And in this case, how many cubes are there in the middle per face? There are 4, right? So it's going to be 4 times how many faces are there in a cube? 6. So it's going to be 24. How many faces are, how many cubes don't have any faces that are colored? It's basically the same as how many cubes are hiding inside of this 4x4x4. And you can see that it's actually going to be this little 2x2x2 cube. So if it's 2x2x2, you can just multiply them all out, and then you can see that the number turns out to be 8. We can try something similar for 15x15x15. And I'm definitely not going to draw this because, yeah, how many cubes are there? It's like thousands of cubes. So yeah, I'm definitely not going to draw it. I mean, if you're quarantined or if you're like self-isolating and if you have time to spare, then definitely feel free to draw all, like, what exactly is this number? 15 times 15 times 15. Yeah, 3,375. So yeah, if you're social distancing and if you have like a lot of time to spare, then feel free to draw 3,000 cubes. I won't stop you. All right, so for 15x15x15, the number of cubes that have 3 faces that are colored are again the ones at the corner, which are exactly 8. For oh my god, sorry. Where was I? Okay, yeah. So for the number of cubes that have 2 faces that are colored, the number of cubes that have 2 faces that are colored, we're looking at the edges and how many cubes are there going to be per edge. It's actually going to be 15 minus 2 because the corner ones are not going to count. So it's going to be 13 times how many edges are there? There are 12. So it's going to be 13 times 12, which is 156. How many faces have one face? How many cubes have one face that is colored? We're basically looking at, for this diagram, it's going to be the ones that are in the middle. For 15x15x15, it's actually going to be 13x13 square. So it's going to be 13x13 square per face. So how many faces are there? 6. So it's going to be 13 times 13 times 16, whatever this is. Let me quickly check with a calculator. 1,000, oh god, okay, 1,014. And how many faces that are, how many cubes have 0 faces that are colored? It's the 13x13x13 cube that's hiding in the middle, like hiding right at the center. So that's going to be 13 times 13 times 13. I'm not going to bother calculating this. Yeah, whatever this is. All right, so now the question is between let's see, the number of cubes per edge, which is going to be, let's call it n. So for the 15x15x15 case, n is going to be 15. So between the number of cubes per edge, n, and let's say a is going to be the number of cubes, that's a u, that have 3 faces colored. Yeah, the lighting, okay, yeah, the lighting is kind of meh, but all right, so that's going to be A. B is going to stand for basically the same thing, but for 2 faces. C is going to be for 1, and D is going to be for 0. And the question is, there are technically 4 questions. Are N and A in a linear relationship? Are N and B in a linear relationship? And then all the way down to are N and D in a linear relationship? Let's have a look. So we looked at 3, we looked at 4, and we looked at 15. Let's see, okay. Let's look at it for A. For A, the number of cubes that have 3 faces colored. So when n is 3, we had A equals 6. And when n equals 4, we had A equals 6. And when n equals 15, we had A equals 6. Right. Is A in an arithmetic progression? Yeah, because the common difference is going to be 0 all the way for basically any n, right? Well, we basically have like one exception. When n equals 1, when it's 1 by 1 by 1 cube, then the number of cubes that have 3 faces colored is going to be 0 because all 6 faces are going to be colored. But let's not worry about this exception. Let's worry about when n is greater than or equal to, when n is greater than or equal to 2. In this case, you can see that it's actually in a linear relationship. All right, let's look at for B. For B, it's the number of cubes that have 2 faces that are colored. Okay, so let's look at it for B. When n is 3, let's see, B was, oh wait, there's something on the sheet. B was 12. And then 4 was 24. And then 15 was 156, whatever this was. All right. It's kind of hard to see whether this is going to be in a linear relationship or not, but there is a way of seeing the relationship between n and b. And one way of doing it is, as n increases by 1, you can realize that the number of cubes that are on the edge, actually, per edge, the number of cubes actually increases by 1. So overall, since there are 12 edges, if n increases by 1, b is actually going to increase by 12. So the common difference is going to be 12. This is in an arithmetic progression, so n and b are in a linear relationship. So A is in a linear relationship, B is in a linear relationship. What about C? Well, let's have a look. So for C, when n increases by 1, we can see that when n was 3, C was 1, and when n was 4, C was 4. And let's have a guess for n equals 5. When n equals 5, per face, this is 6 because it's going to be 1 times 6, and this is going to be 24 because it's 4 times 6. Yeah, so this is going to be 1 times 1 times 6. This is going to be 2 times 2 times 6. When it's 5, in the middle, there's going to be 3 by 3, and they're going to be 6. So it's going to be 3 times 3 times 6, which is 54. So immediately you can see that this is not an arithmetic progression because the differences are not common. So C is not in a linear relationship. And it's your exercise to see that D is actually not in a linear relationship either. Sweet. So that was question 4. And hopefully I have enough space to actually fit in question 5. Oh no, question 5. Okay, question 5 and the last 3 questions, they seem quite long. So I'm going to have another video for that. So this concludes the second video. I'll be right back with the third one.